Hello friend, this is Dr. Avinash Chand Yadav, Assistant Professor, Department of Physics, Institute of Science, BHU. Today I am going to talk about some elementary concept from the probability theory, especially useful for physicists. So these will cover microstates, macrostates, sample space, probability distribution function, that is a mathematical object, and the physically important objects are mean, variance, relative fluctuations. They can be calculated using probability generating function. So I'll show this using one very simple toy model. Consider n unbiased coins and throw them simultaneously. So you will get a configuration having a string of heads and tails. You know that each coin have two possible states, head and tails. If there are n coins, so we can have 2 to the power n number of microstates. This is discrete, so it's a sample space is basically finite. Tracking the state of individual coin is not easy task and also not desirable. One can think of some macroscopic property of the system like total number of heads or tail, like that. So the macrostates one can define like nm, nh or ht. So eventually one may be interested in knowing what is the probability to observe h number of heads in a given trial. For fair coin it is given by expression 1. In general, if the coin is not fair and the occurrence of head occurs with probability p, small p, the corresponding complementary probability is q, 1 minus p, then it is given by binomial distribution function, and it is easy to check that the expression is well normalized. If you sum over all possible h running from 0 to n, you will get 1. Now let me tell you how one can use the probability generating function concept in order to calculate various important quantities of interest. So equation 2 gives an expression for probability generating function. It is basically probability multiplied by x to the power h, and then there is a summation sign running from 0 to n. So eventually we get a simple expression px plus q to the power n. Its normalization is easy to verify. If you set x equal to 1, then p plus q will become 1. 1 to the power n is equal to 1. So it is well normalized. Now the computation of first moment is also easy. It is given by expression 3. If we differentiate probability generating function with respect to x and then set x equal to 1, so that will give you mean. So if we calculate this quantity, will get n of p given by equation 3. Similarly, the second factorial moment will be given by taking second derivative of the probability generating function and setting x equal to 1. So this will give you n minus 1 p square. With the help of these two, we can easily calculate the variance. In this case, variance comes out to be npq. Standard deviation is given by under root of the variance. So it is under root npq. And relative fluctuations, that is standard deviation with respect to mean, is equal to 1 over under root n times under root q by p. When q is equal to p, then this expression will simply reduce to 1 over under root n. This 1 over under root n tells you how the error will reduce. So this is an important aspect. So let me stop here.